Good afternoon and welcome to the University of the Free State Libraries. What an honor to be sitting to the world-rated, highly cited #1 professor in applied mathematics, Professor Atangana. Welcome to our UFS Libraries studio.
Thank you very much for inviting me. Thank you.
Yes, today we want to zoom into the preprint that just came out 2 weeks ago, where you're talking from complex models, theorems, and systems into new structures. We want you to lead us into understanding, to unpack what is this means to us in layman terms. I have some key questions. I want us to start by looking at, please explain to us, what is a fractional derivative?
Okay, thank you for asking that question. It's very important because God gave us a purpose. He told us, go in the world, multiply and control the world. And when they speak about controlling, you need to do prediction. And to do prediction, you must have an operator that will tell you if the function that you study increase, decrease, or is constant. So the first idea was introduced by Newton and Leibniz, where we are talking about classical derivative. This tells you exactly if my function will increase. Of course, that is our life. Is my salary increasing? Is my kid doing well in school? So those are the variations that we want to know. So the classical derivative was introduced by Leibniz and Newton independently and have been used for classical mechanics. So we have what we call first derivative, second derivative, third derivative. So if you differentiate that operator function many times, if it is n time, then what if that n is a fraction, for example, 0.5? And the question was asked by L'Hopital to Leibniz. He asked him, what if my n is a fraction? And at that point, they were not able to answer the question. And he said it's a paradox. And a paradox that will grow serious conclusion and open door for many research in the future. So there are some work that have been done by several mathematicians, for example, Riemann, Liouville, Cauchy. They did a good work until they came out with what they call a fractional integral. So from the fractional integral, they were able to build what they call a fractional derivative. So let me give you an example to see the difference between classical derivative and fractional derivative.
Yes.
The one you are speaking about, instantaneous change, that means you see a change, a rapid change.
Yes.
Then we can speak about velocity. When you enter your car, you will say that I was going to Johannesburg, I did 200 kilometers per hour, for example. So that is the velocity. Now, when you accelerate, then you talk about second derivative. So you have the first derivative is we can speak about velocity. Second derivative, you can speak about acceleration. But when you are driving from Johannesburg to here, you are not only going with the same speed and the same acceleration, you change. So a fractional derivative will take into account that history. So it is like a global derivative, a global rate of change, a global velocity.
Okay.
Yes.
All right. Out of this talk, I'm going to be very educated. Okay. Right. What is the core problem and the motivation behind all of this?
Okay, so let me just give you a small example. Imagine that there is water. We have, for example, in our site here on campus. So we have water that is flowing underground. And we'd like to know what will happen, how that water is flowing. Because when the water is flowing through a geological formation. It means that the geological formation will give the momentum, it will tell the water how to flow. So what is happening is that you go there, you want to tell, for example, a farmer that, you know what, your aquifer has this number of quantity of water. If you take it out, with this rate, you will deplete your aquifer, for example. So what we do is that we go there, we take the measurement, we come back, we build a mathematical equation, and we use a derivative, as I told you, because it is for prediction. We use the derivative, so we have what we call a mathematical model that represents that real world situation. So now we solve our equation and we compare it with data. If there is a deviation between the data, it means that either your data are not correctly recorded or your mathematical model is wrong. So now if you notice that your data are correct, then you have to revise your mathematical model. So we have now our data are correct. So we notice that there is a specific problem in the geology that our classical derivative cannot consider. That is, for example, the presence of fracture.
Okay.
So what we do now is that, we build this system using fractional derivative, and we solve that system and compare it with data. If there is an agreement, then we know that, the system was not responding to the classical derivative, it responds with fractional derivative. So what is the motivation about my work? Why did I decide to introduce this concept of integral? Because when you have a derivative, you must have an integral, because derivative give us what we call differential calculus. An integral gives us integral calculus. So the derivative is like the inverse operator of the integral. So the integral also is the inverse operator. What does that mean? It means that if I take somebody here, for example, I bring the person there, then the inverse means that person will take that person abroad there and bring the person back here. So the big problem that we had in our community of fractional calculus is that we have Riemann-Liouville derivative.
Which were the first models?
Yes, the first one. Then in 1965, Capito came out with a fractional derivative in capital sense. And now, the fractional derivative based on Capito experiment was observation from the real field. So it is nature that asked him to obtain that derivative.
Yes.
So he observed it in nature. And as I said before, the nature is more important because it is from nature that we can formulate a model, So now we have this fractional derivative Capito and we have Riemann derivative, but we have only one integral. So it means that there is one operator that will be used to inverse Capito derivative and Riemann derivative.
And the other one, yeah.
So I, as a young student, I asked question to some elders to explain to me why.
Why you use one?
Yes, for both.
For both models.
But when I look at the structure of Capito, I can see that Capito is more natural. It's not artificial. It's not mathematical manipulation.
Okay.
Then now, I asked them, can we have an integral that will be the inverse of Capito derivative? They told me that our culture, since we have been doing this thing, we are only using Riemann.
Yeah.
But this is the problem. If you apply Riemann fractional integral on Capito derivative, we obtain what they call initial condition. That initial condition is not, we don't know how to calculate it. So in mathematics, we call it unusual initial condition.
Oh, yeah.
You see? So now, those unusual initial condition.
Sorry, Prof, to interrupt. Does this mean now if you say you can't interpret, so it stays like that?
Yes,
it stays like a problem?
Yes.
It is a problem.
It is a problem.
Unsolved problem.
Yes.
Okay.
So that is the problem I'm asking myself. Capito derivative, when you use it, you can see that we have initial condition that you can say that when there is a process, what is the initial condition? It is the state when t is equal to 0 at the initial time. The process has not started. How is that state? Let me give an example. Go to the lake. Let us say the lake is there's no movement in the water, so the water is horizontal, no problem.
Yes.
That is the initial condition. So it take now a stone and put inside.
Throw it in that
Throw it inside. What do you see? You will observe the wave. So what was the initial condition? It is when it was like this, then the wave.
Calm. Yeah.
You see the proper. Now, I went to many conferences. And I asked senior people, why do we have this fractional integral of Riemann that we use to invest the capital? And they told me that is our culture. So for many years, I saw that it was wrong.
So it was troubling you?
Yes. Not only troubling me, even themselves, even everybody, because we are dealing with initial condition that we cannot give an interpretation.
Oh my word. Yes.
You know?
Yes.
So I decided since 1 year to investigate on this problem. I will introduce a fractional integral that will be invertible with the capital, so that we separate the two calculus, Riemann calculus and capital calculus.
To have its own.
Yes. So
solving.
that was my motivation.
Wow. Prof, I'm Leonard. I'm educated as of today. So tell us a bit more about the breakthrough of the Atangana Integral.
Yes. First of all, why did I decide to call it Atangana Integral? Of course, I have already many operators that are named after me. It is decolonization. You know, when people speak about decolonization, I don't see it in that way. It is decolonization in the sense that an African child, when he take any book, he only see Koshi, Syrian man. He sees only the name of the people from the West. And if you are a curious child, you will ask yourself, what about Onana? What about Shabalala?
What about Dlamini?
We did not do anything.
What about Shaka?
Yes. Does that mean we never do anything? It demoralizes you. When you have a discussion with a guy that comes from Oxford, he speaks with confidence, not because he's good, because he is speaking knowing that his people have introduced everything that we are using nowadays in mathematics is generated by them, is named
West.
after them.
Yes,
So
yes.
when I then introduce this derivative, this integral, the first thing is to prove that what has been done before was wrong.
That was the big part.
Yes. So I proved that what has been done before was wrong. Because you are introducing into the system, I think mathematicians will understand what I'm saying. You are introducing into a system fake initial condition, if I can, fake memory. And now, when I use my integral, I'm able to bring initial condition naturally. So that was the breakthrough of this research. So, and this have ramification in many things, because when you are using, you have a partial differential equation or ordinary differential equation that has capital as a derivative. Let me take you an example. Epidemiology. We are speaking about the spread of disease. You model it using fractional derivative of capital. So you have to solve it. Sometimes we use the inverse. So it means that we use the Riemann. So when we use the Riemann now, my system now is not proper to capital framework. There is an artificial singularity that we have introduced. So it is like an accumulation of memory. So using my derivative, that does not happen. My integral, that does not happen.
Okay.
So I use it directly. When I use it directly, I bring back the correct memory in my system. Then now I can solve my system and compare it with what exists in nature. But in mathematics, it goes beyond that. It goes beyond that because sometimes we want to prove if the system has a unique solution, and this artificial singularity gives us problem. And sometimes people assume that it is a constant and they try to do something, but it is like how can I say it?
Like quoting the problem.
Yes,
Yeah.
like they just to manage. So that was what I did. And now from there, I can go beyond. It create new theory in terms of inequalities in mathematics. It create many, many, many things.
Wow, Prof, this is amazing. I'm telling you. So looking at it now, how do you view it's going to be recepted?
In general, when something comes from our continent, at the beginning, people don't want to, they want to sabotage it.
Because it's from Africa.
Yes. I had a lot of fight, but the University of Free State does not know. I had a lot of fight. You know, when I came here, I was, I don't know how old. So when I started becoming popular, it's not like I decided to become popular. I did something, then the whole world started using it. I received serious attack. Serious attack from a group of people from the Europe, crying, you know. They set many crap in front of me for me to fall. But at some point, if the university was not aware of it. It is one day that they set me a trap, and I did not know, you know, and they came after me. Then I called the rector. I told him that when you have a top guy in your university, if you say that I'm a top guy, you must look after me. From time to time, just call me and ask, how do you do things? Because you don't know what I'm going through.
In real life.
Yes.
Yeah.
So no matter how people will say, whatever they will say, that is the completion of the paradox of Leibniz.
That has been there for
Yes.
years and years.
For years.
And people couldn't solve.
Yes. So this is the completion. Because the real fractional derivative is the capital. It comes from the nature. And the real integral associated to it is the Atangana integral. So it will change everything in the field of fractional calculus. And already, you know, when it was published on Archive, I received more than 40 messages from all over the world.
Oh my God.
Some asking me, how did you get this idea? What motivated you? Because we have been using this thing for many years.
We've been trying.
Yes.
And
So
failing.
tell us, just tell us, you were sitting eating, then you say, let me introduce this integral. Can you explain to us what
inspired you
But
to?
it is already receiving attention from
All over the world.
yes.
Yeah. Prof, I don't want us to go any further than that. Now that you talk of attention, at your age, you are at H index of whatever number that is. That is very high. That is very big. So it also shows how your research has been used across disciplines.
Yes.
So how do you keep up in producing quality, not just quantity, but quality of research?
You see, as I told you before, at some point, the top management, they think that I do it to impress them. No. I don't do it to impress the top management. I don't do it for myself. I have a target. Before I die, an African child will be proud.
Yes.
That's why I don't want to think using the foundation that was laid by the other people.
By someone else, yeah.
That's why I try to create something that they will say, okay, it's coming from Africa. There's nothing good coming from Nazareth.
Yeah.
But Jesus
came
from there.
Yeah.
So I always ask questions, try to understand and try to see the limitation of what exists. And ask myself, what can I do to make a mark?
Yeah, great.
So the paper, it was first of all 78 pages. Normally, an average paper in mathematics is 20 pages.
Yes.
So I wrote it, before I checked, it was 78 pages. So I spoke to some people, I said, but this is almost a book. Just continue.
It's like a chapter,
Yes, just continue. So that is the reason why I keep on introducing many things new in the literature. Let me tell you something, if I still have time. This year, I had a problem many years ago. In mathematics, there's something we call complex number. Complex number, it is in a plane. What happened is that we are speaking about complex number. From there, we speak about trigonometry. From there, we speak about angles. From there, you can extend it to whatever you want. So this complex number has one imaginary and a real number. So it is 2 dimension. And as a curious African guy, I never see anybody in 2 dimension. When I look at the sister in front of me, I'm not seeing her in 2 dimension.
Yeah.
I see her in 3 dimension.
Okay.
I see her in 3 dimension. I can see her in X, Y, Z.
Okay.
But what they are telling us about trigonometry is the angle. It means that I only see her X, Y.
Not the other part.
Yes. So other people introduce what they call quaternium. Quaternium now is a complex number with 3 imaginary. That means we are in a 4 dimension. Although I'm very faithful to my wife, if I see a woman that is in 4 dimension, I may be tempted to ask her out. But I never see a
You
woman.
never met.
I never met a woman in 4 dimension.
Oh my goodness.
So because I want to be real, I want to be pragmatic, I want to be in our
in the real world.
Yes. So what is this? And I told myself, let me create a complex number that is 3 dimension, but that can deform. And what was my big problem? My big problem was that when they speak about me, they say this is Atangana. But this Atangana keep on deforming. So when I was small, I was like this, a baby. Then I keep on increasing, At some point, my heart stopped, but sometimes my stomach come
out. Yeah.
Yes, it becomes slim again if I do sport. So that is what they call deformation.
Okay.
And complex number cannot actually explain that. So I introduced this year. It was also a very hot cake. I introduced what I call trination. Trination come from, I told myself, three trination. Trinity. I call it trination.
Like that, yes.
That trination is under in press now to be published officially.
Oh yeah.
That has changed everything.
Wow.
In complex number. So that is the reason why I try to ask myself, what can I do to make sure that Africa is attracting attention?
It's a better world, yes.
Not to impress the research department of my DVC.
So it's within you.
Yes.
Yes.
Not for myself, but for the future of the next generation. They will be proud to say, clinician was introduced by an African person. This integral was introduced by an African person. This calculus, this numerical scheme, this. And they will also be able to speak with confidence.
Thank you for that, Prof. Can I ask also on this part of decolonization of the discourse of learning, will it be possible in some years that our children can learn mathematics in their Zulu and all the mother tongue languages? Do you think it's a possible thing to come?
Let me tell you what I think about this subject. Few years ago, I was invited in Tanzania by the former head of state. Kenyatta, the one from Mozambique, most of them, they came there. Our discussion was around, look at us. What are we speaking? We are using English.
English, yeah.
To speak. Can we not use an African language to speak?
In Africa.
And this is a very big inconvenience for me because I learned French in Cameroon. And my language is Eton. So you see that for me to do mathematics, I have to think in English, or first of all French, then I translate it in English, bring it back. It is very complicated. So our aim was what? Is it possible for us to have one language in Africa?
That can be used.
That can be
standardized across.
Because the European guy understands better some theorem because he understands that theorem in his own language. But me, I have to do serious effort. I have
translating and this and that.
I went to school doing French. I have to translate things from English to French first. Sometimes I want to translate them in my mother tongue. Then I believe that we can, under the condition that we see Africa as a country. A country that were divided by the West. So if we decided to sit and create, if you can call it African Academy or something, where we are going to put people that are expert maybe in Swahili, chemists, mathematicians, we put them in one room. We leave them there for 1 year. Yeah. So that a mathematician should give a word about what they call integral in that language. So that a chemist will say, Chitosan will be this in that language. We will build a solid foundation that will make our kid to learn, mathematics in our language.
That will be a proper paradigm shift ever in the world.
Yes.
Prof, maybe this will be the last question. Back at home, if your grandparents are still alive, how do you explain to them what you do here? What do you do? What do you do? What is your work? What do you do?
That's a very good question. My grandmother died, but before she died, she was asking me, I'm hearing that you are creating some things, formula or something. What does that mean?
Yes.
So, what can I tell to my grandmother? I told her that, okay, look here. Imagine, for example, you have your farm of cocoa, for example,
Yes.
and you would like to have a good, at the end of the year, you want to have harvest more.
A good harvest, yes.
So what will you do? Then she will tell me, no, I will do this, I will do this, I will do that. I will tell her that you see all those things that you were talking now. I can pre-formulate it using something they
Numbers.
call X,
Yes.
something they call Y,
Yeah.
and I form a model
Okay.
and I predict
What's
what
going to happen?
is going to happen.
Wow.
And that is the reason why, for example, when I was in my country, Cameroon, I was on the media every minute, CRTV, and people were asking, how important is mathematics? And I told them, as I started before, God told us, go multiply and control. To control, you must observe. That means collection of data. You must analyze the data. Then you must formulate that data in terms of a model and solve that model and predict the future. A clear example is when the COVID started. I was the first mathematician here in South Africa to write a model. And I wrote this model. I told people that we are going to have a lot of people that will die and a lot of people. Some people say, no, it's just mathematics. But there is one journalist, I don't know whether I don't know. He was following my trend. And hey, are you a prophet? I said, no, I'm not a prophet. I took time to properly build a model that can be used for the future. So that is what the West is using. They use it to predict what will happen in the next 20 years. And they solve that problem now. So that in the next 20 years, that problem will not occur again.
So in essence, we can agree to say applied mathematics can be the foundation to solve the real life problems.
All
of
the problems. I'm telling you all. Just tell me one problem that mathematics cannot solve. God is a mathematician. Let me just tell you one is, this lady is beautiful. Why are we saying that she's beautiful? It's because God used what they call symmetry. Otherwise, you could have one eyes here, another eyes here. But God put eyes perfectly so that there is a symmetry.
So now we can see God's modeling with
yes,
the lady.
I'm seeing
Thank
God
you so
modeling
much.
everywhere.
Prof, it was lovely to speak to you. Thank you for your time. We know you are a busy man, and thank you for honoring the invitation.
Thank you very much.
To our viewers at home, this was a lovely afternoon for us. Great discussion with our professor, and thank you for being here with us. See you on the next show.